Adam Rees on the cosmos and how we perceive it, a Nobel Prize laureate cautions us that even if we ignore measurement mistakes, there is still a genuine and fascinating chance that we have a misunderstanding of the cosmos. The James Webb Telescope provides evidence that the universe is experiencing an unusual event. Our universe would have undergone a bizarre shift that cannot be explained if we accept the most recent readings from the James Webb Telescope. However, what would that actually mean? Do we have a fresh explanation already, or are we truly helpless to stop the most recent developments? One of the most prominent cosmologists of our day is Adam Rees. The Nobel Prize laureate found a concerning disparity in the Hubble constant readings and presented groundbreaking research on the universe's expansion years ago. These variations from previous measurements were dubbed the Hubble tension. Rees eagerly anticipated the James Webb Telescope's launch, as were hundreds of other scientists worldwide. The true nature of the cosmos would finally be proven by the new technology. We would finally have clarity if we had answers to queries like whether Rees's measurements were incorrect or if the previous measurements were incorrect. Of course, it was also possible that the Hubble tension was an unexplained phenomenon, but at the moment, no one wanted to acknowledge that possibility. Scientists were taken aback by the Webb telescope since the most recent measurements verified the precision of every earlier measurement, ruling out a pure measurement error. Increasingly, it is clear that the discrepancies in readings are not caused by inaccurate observations made by our telescopes. Both Hubble and Webb performed two measurements, one with Type 1a supernova and one with Cepheids as standard candles. In this context, standard candles are measurement constants that scientists employ to leverage the absolute brightness of these phenomena to obtain precise measurement findings in the cosmos. In actuality, the outcomes of the two measurement techniques ought to be comparable. It measured the expansion of the universe, or more specifically, the rate of expansion and the acceleration or deceleration of the expansion. The difference is so large that Adam Rees believes the Hubble tension is pointing us to other fundamental misconceptions about the universe. Smaller measurement discrepancies would have indicated a difference in the absolute brightness of the standard candle and would have been physically explicable. Adam Rees has discovered the reason. Adam Rees is the father of dark energy, in case you were unaware. Rees, Brian Schmidt, and Saul Perlmutter shared the 2011 Nobel Prize in Physics. The three scientists received recognition for their unique finding that the cosmos is growing and expanding at a faster rate. The researchers were also taken aback by this discovery because, in reality, the cosmos should be slowing down. Consider how the universe sped off, generating matter and occupying ever-increasing space, after the Big Bang was in initial energy. In fact, it should eventually slow down in accordance with current physics. This notion that the cosmos will someday run out of steam, so to speak, gave rise to the Big Freeze theory, which holds that at some point in the far future, when all energy has been used, all processes have stopped, and the universe has essentially frozen. The universe will finish up in a state of shock. However, Rees and his colleagues' measurements revealed that the universe's expansion is speeding rather than slowing down. However, how is that possible? The idea of dark energy was first introduced as a result of this paradoxical finding. The enigmatic fast expansion of the universe is believed to be caused by this force, which has not yet been observed or quantified. Before the James Webb Telescope was launched, the Hubble Space Telescope was utilized to verify these theories. Adam Rees is employed at the Space Telescope Science Institute, which is in charge of the Hubble Space Telescope, in addition to being an astronomy professor at Johns Hopkins University. Rees's theory is supported by the James Webb Telescope. Take a moment to consider how you perceive the universe. Can you see that this space is growing larger and larger, and do you also picture a place with rotating, turning, creating, and destroying objects? Although this idea may sound a little absurd to us, it is true that the cosmos exhibits evidence of expanding its overall space on numerous levels. Up until now, the expansion of the cosmos from a starting point was the only plausible explanation for these phenomena. However, as previously said, the universe would eventually need to slow down, or at the very least, it shouldn't continue to expand at an ever-increasing rate. This is where the special mission of the James Webb Space Telescope comes into play. NASA's newest telescope has already demonstrated numerous events that support Rees's idea in its 2 years of operation. Some of these galaxies are so old that they shouldn't be there. Moreover, no evidence of a dark age or actual remnants of the Big Bang has been found thus far. Webb has allowed us to observe groupings of galaxies so enormous and far-reaching that they cast doubt on the idea of an isotropic cosmos. All of this, along with the Hubble tension phenomenon, supports the theory that our current understanding of the universe is inaccurate. It's now possible that these new discoveries will cause significant shifts in science. Adam Rees is not the only one who recognizes the significant obstacles that the scientific community is currently confronting in its understanding of the Earth and the cosmos. An increasing number of scientists acknowledge that cosmology's unresolved mysteries are compelling us to reconsider. It is confirmed by drastic changes in the universe. Who would have guessed that our entire cosmology could crumble due to a little telescope? No one anticipated these observations, despite the fact that the James Webb Space Telescope is the finest telescope ever constructed by humans, not just any device. It seems as though the researchers are suddenly looking at a different universe than the one they believe to be their own. There are signs that the cosmos is older than previously thought, and that galaxies develop more quickly and in a different way than was predicted by earlier ideas. The thought that the cosmos is limitless might possibly be something we need to adjust to. We might not even have a complete knowledge of the origins of matter. Additionally, James Webb makes observations that raise questions about the existence of dark matter. Another tenet of the previous ideas will have been lost if dark matter is not genuine. However, how can we then account for the phenomena that gave rise to this enigmatic substance? Scientists like Fritz Zwicky and Edwin Hubble made the prediction that matter must exist in an invisible form. The incoherent spinning behavior of galaxies and other phenomena could only be described with the aid of this type of stuff. Although they are not as cogent, there are some alternative theories that could account for similar events in the absence of dark matter. Additionally, Webb demonstrates that there may be problems with the notion that the cosmos appears the same in all directions. Scientists refer to this uniformity effect as isotropy. The traditional cosmological paradigm is further upended if this isotropy is absent. To explain the universe's accelerating expansion, Rees and other scientists proposed the idea of dark energy in the early 2000s. Like the presence of dark matter, the existence of this type of energy has not yet been established. It is anticipated that the mainstream model of cosmology will soon undergo a significant revision as a result of these new findings. But now, where might this shift take us? We are in awe of these fresh perspectives. Assume that there are no physical constants in the universe where we reside. That would imply that physics varies locally and even across time in our universe, that standard candles can never yield the same findings, and that Einstein's notion of the constant speed of light is false. Following the most recent JWST measurement results, these issues were raised, and the most recent hypotheses go even beyond. There are theories that see intelligent forces in dark matter or dark energy in addition to the notion that our physics can only explain a portion or an aspect of the cosmos. This would imply that the universe has a soul or intelligence of its own, which could help to explain who and why the universe was formed. If such wild ideas were proven true, we would at least know that there is such a thing as creator intelligence, but we would still be a long way from having actual answers to our problems following such knowledge. Up until now, scientists have always sought to explain the cosmos by examining matter and light, but it is increasingly becoming clear that the structures we seek are found in the enigmatic darkness of the universe, of all places. We will need to keep an eye on what is happening in front of us, what measurement data we obtain from the most recent Webb observations, and what that means for our research, because this hasn't really been demonstrated either. In order to find out who or what created the universe and why it exists, humanity started to investigate our surrounds and eventually the cosmos. It's possible that we are at a turning point that will drastically alter our pre-existing perspective, akin to a scientific and knowledge revolution. Less audacious hypotheses merely assert that our world may not have a beginning or an end, or that it is much older. However, where are the indications of growth coming from? There are intriguing new theories that imply that regional currents affect our universe here as well. It can be compared to a wafting bubble formation that varies in acceleration and expansion rates and collapses or expands regionally. It makes perfect sense if the Big Bang never happened. It should come as no surprise that there has also been no solid proof of the Big Bang. We have never seen any concrete proof for the idea of a starting point some 13.8 billion years ago, but for a while, the fact that all the hypotheses fit together very well seemed to support it. There is more proof that our outdated perspective is flawed if we examine quantum and particle physics again. We know from the quantum realm that our universe must be far more malleable and changing than previously thought, and you might be shocked to hear that particle physics has yet to produce any proof of the actual physical existence of matter. However, our cosmology is founded on the observation of material occurrences, and scientists have inferred types of energy and forces from the behavior of matter. This might have been an obvious error,